Hello all, welcome back to my channel. In this video, let's take a look at classification report and why this classification report is very much important. Let's deep dive into the collab, and then once after we prepare the code, we will take a look at the theoretical part. Okay, so if you have not watched my previous videos, please do watch. This is a continuation to that. So from Scikit-Learn, okay, let's do confusion classification report. Okay, so let's see. Let's import the library from sklearn.metrics. Import classification report. Cool. And then print classification report of actual y test, actual values and the prediction values. Okay, let's run this one. Okay, now it has generated four things based on labels for 0 and 1. So it has given precision, recall, F1 score, and support. And here let's take a look at what is precision, what is a recall, what is F1 score, and also do remember that. So it has given precision specifically for zero label and for the separately and for first label separately. So if you remember our data target df dot target dot value counts, so it has zeros and ones. So this is on based on this, it has given the precision, recall, and everything. Let's deep dive and let's see what is this one. So what is a classification report? So you have to practice this chart. You have to remember this one. So on this index, I have actuals no, actuals yes, and here the predicted no and predicted yes. So Tn represents true negative, and TP represents true positive, and Fn represents false negative. FP represents false positive. Let's see how this works. So if the actual value is no, and if the predicted value is no, then it is called Tn. Okay, it's a true negative because the person don't have any disease and the predicted has no disease, so this is totally fine. And if the person has no disease, but if the prediction it has S, this is a wrong value. And if the person has disease, and if in case if it is predicted as no, this is also a wrong one. If the person has actually disease and the predicted is yes, this is a correct one. So actual no and predicted no is a correct one. Actual yes and predicted yes is a correct one. And false negative and false positives are the bad ones. So how I can find the accuracy of this one? Accuracy is equal to true negative this one plus true positive divided by number of count of records. So this is the actual ones. And the precision, how we can get to know? So precision, what is the precision here? So actual is s, and the predicted is s. This is the precision. And here if you see actual is s, and this is uh, uh, and it should not be false positive. So here actually is no, but the predicted as yes. This shouldn't be there. So that's the reason what I did. TP divided by TP divided by, I mean, I wanted this one, not this one. So we have to divide this one. TP plus FP divided by. And the recall, quick mistake. Okay. Yep. So, and the recall again. So actual is yes and predicted is yes, but not this one. Actual is and predicted no. Let's not this one. So TP divided by TP plus F1. So correction is here. Sorry for that, guys. I mean, ladies and gentlemen. And recall, it's a mean of precision and recall. So one thing you guys have to remember that it's not a normal average, it's a harmonic mean. So what is the difference between a normal average, normal mean, and harmonic mean? Let's take a look at this one. Believe me, guys, for me to figure it out all of these in depth, it took me almost like 2 years, and I'm putting everything in one video for you. So let's take an example. Let's assume that there is a destination to a city called Bangalore. So two cars, car one and car two. Okay, the destination, the distance that they have to cover is 100 kilometers, and one car traveled for at a constant speed of 100 kilometers per hour, and it has reached in 1 hour. And the second car, it has traveled at 50 kilometers per hour to cover the same distance, and it has reached in 2 hours. Now, usually, what we will do for the average, we will do like 100 plus 50 divided by 2. So, if we do this one, we'll get something like 75. So, this is the normal average that what we calculate. But what one thing that we have to remember is that we have time in consideration, and we're forgetting the time taken over here. So in these cases where the time is like most important factor, you have to consider the harmonic mean. So what I did here? So there are two divided by 1 by 100 plus 1 by 50. So this is the average time. So this is the harmonic mean. So do remember that. Now let's jump into our collab. So here this is the precision, this is the recall, this is the F1 square, which is the harmonic mean of precision and recall. And again, this is for zeros and ones separately. And for the support is nothing but how many samples that they have taken to calculate this one. For zero, it has taken 100 samples, and for one, it has taken 105 samples. And you can see the accuracy as well, which is 100%. And how many samples it has taken? 205 samples. So this is how you can predict the classification report. And this data set, because it is giving everything in like 100 percentage. After this video, I will take one more different data set, and let's deep dive into that. And um, and I will add some variance to the data set so that the precision will be like somewhere like 85%, the recall will be something, and F1 square. Do remember, guys, this F1 square for zeros and ones, it is like 1 1, which is fine. But if in case if it is like 40 for zeros and 80 for ones, this is called imbalanced data set, which I will cover in a different video. Thank you for watching this video.